Well, hello everyone. Looks like we're live now. Hi everyone. Good morning, good afternoon, wherever you're based. My name is Dalia and I'm from Elastic's community team. And we're very happy to have you here today. The topic of today's presentation will be what Elastic Agent and Fleet look behind the scenes. We have Nicolas here. He will introduce himself and walk you through this awesome topic. We always look for presentations, so if you ever want to present at one of our meetups, please send us an email at meetups@elastic.co and we'll arrange it. You can ask the questions during the presentation.
So over the past 2 years, I kind of helped kickstart the whole Fleet Elastic Agent project, and I'm now kind of on the tech lead side of that project. And today, I want to give you some insights on actually how it works behind the scenes. So I hope many of you had a chance over the past few months to try out Elastic Agent and Fleet. So today, you're going to see a bit more technical details. I said a bit more. It's actually a lot of technical details, so it's going to be a pretty technical talk. So first, I want to give you a very quick architecture overview on how the whole monster that we built looks like. And there's a lot. So on the screen, you actually see all the components. And let's start with the agent, the Elastic Agent. You see it down here. The Elastic Agent is actually a supervisor. It runs file beat, metric beat, and so on. It takes data like logs and metrics and ships it to Elasticsearch. That's what you know from beats. What it does a bit different than actually beats is the way it indexes data. It ships it to data streams, and there's actually another talk. I talk about data streams and the data stream naming scheme, but it's a new format, new indexing structure we use. So there is a mode standalone, and there is actually a mode with a policy that enrolls into a Fleet server. And now we actually can centrally manage these Elastic agents over here in Kibana. Elasticsearch is used as the communication layer. And in Kibana, you basically have two parts. You build a policy on what should be collected and how, and you have the so-called package manager. Many have seen that as integrations. So what it does is when you want to collect logs for Nginx, it actually goes to the package registry, which is an online service, downloads the definitions on how to collect Nginx data, which log files to collect, installs dashboard, ingest pipelines and templates, and does all this. So that is kind of all the things we talk about today. And I'll come back to kind of that slide. Keep it in mind, there's an agent. It ships data to Elasticsearch. It is configured through Kibana, and there some assets are installed that tell Kibana how to configure the Elastic Agent. And there is a component, Fleet Server, that we're going to touch on. So normally I only look forward on like what is coming next and what is happening today. For this presentation, I want to quickly dig into the story of the Fleet server too, because I assume quite a few of you have used Fleet before 7.13. And there was a big change, a breaking change in 7.13. And some of you may have asked, like, why did you do that? So before 7.13, actually the architecture was simpler. We didn't have a Fleet server. The Elastic Agent enrolled directly into Kibana and Fleet, and the data was sent to Agent. In 7.13, we changed that. We introduced Fleet Server, and actually Fleet Server is run also by Elastic Agent. So now all the communication is actually going through Fleet Server. The policies are stored in Elasticsearch, and Kibana puts the policy there. So we basically introduced one additional component. And the reason we actually did that there are multiple ones. One was scale. So with Kibana, one of the problems we hit was that when we, for example, you enroll 10,000 agents, that actually put a hold on Kibana on like all the other things you were doing. There is at the moment no multi-node support in Kibana yet. That might come. Second argument was around the security and less permissions. So basically, because you only have to expose Fleet Server now, that component is much simpler and has much less permission in the whole stack than Kibana itself. And it also gives you more flexibility. So you can deploy your Fleet server close to your agents and don't have necessarily to deploy Kibana there. So there are quite a few reasons. We went forth and back, should we really make that switch? But in the end, October, exactly a year ago, we said, yes, it's worth it as a long-term investment. Quick note on the compatibility, as we have 4 components. Kibana Elasticsearch should always be on the same miner version. Of course, Elasticsearch is upgraded first, so you're going to go to the next miner first, but Kibana should follow. Elasticsearch should always be newer or equal than Fleet Server, and the Elastic Agent must be the Fleet Server must be newer or equal than Elastic Agent. So you kind of have a chain or a tree of dependencies. If you run it standalone, not managed, the thing that we enforce today is that the Elastic Agent needs to be older than Elasticsearch. It's actually something we always recommended for beats and never enforced. Now we enforce it to actually make the compatibility simpler. So from here on, the only thing we're going to talk about is the new architecture. I wanted to show you quickly the old one in case you still had in mind, oh, my Elastic Agent connects to Kibana. It doesn't anymore. There is only a connection to Fleet Server, and Fleet Server only talks to Elasticsearch. So from here on, we're going to go technical. So lean back, enjoy, and please ask questions directly in the chat. So not that we have to go back in the end and kind of re-explain the whole topic. Type your command. I'll see it here on the right side and should be able, hopefully, to answer it or actually point you in the right direction. So let's first talk about the Fleet part. Fleet is a plugin in Kibana. Consists of 3 components: the package manager, which is what I showed you before. It pulls down packages from the registry. Think of the registry as something like npm registry. It's a glorified zip files. It takes the assets and puts it in the stack as dashboard, visualization, ingest pipelines, index templates. Then we have the policy builder. It builds the policies for the Elastic Agent to make sure the Nginx configuration is there, the system configuration, so you can add the things you need. And the last part is the agent management, where you can enroll agents, unenroll agents, see the logs of the agents, basically a UI for what the Fleet Server does in the background. And all the communication happens through Elasticsearch. There is no direct connection. So on how does Fleet actually store the data? So for the installed package, for the policies, for the user setting, we just use the standard mode Kibana has, which is called saved objects. It's a document in Elasticsearch. There are multiple documents, nothing special there. For the installed ES, Elasticsearch, from the packages, we actually keep track of it in a saved object. And then comes kind of the special documents. We call them .fleet star indices. These are system indices. So they're a bit special. You cannot just access them. At the moment, you still can. In the future, system indices have some restrictions in place. But it contains all the data that is needed from Kibana to communicate with Fleet Server. So basically, Kibana writes it down to Elasticsearch, and Fleet Server picks it up. Basically like a pops up mechanism, and actually we use a light version of a pops up mechanism based on some Elasticsearch magic we use there, and we keep iterating on it to have to query Elasticsearch less. So there is a list of these indices. I'm not going to go into detail of each one, but in general, you should understand everything between Fleet and Fleet Server goes through Elasticsearch. So quickly through the UX experience, the Fleet setup. As soon as you go to Fleet, it installs a default package like how you collect system metrics. It creates a policy. It creates an enrollment token. Then you need to enroll your agent. And something that is still the case, we might change in the future, is you actually need to be super user. You have a lot of power if you can enroll agents and actually manage agents. So at the moment, you have to be super user. For the integration page here on the right side, you see a screenshot. That is actually all loaded live directly from the registry. So if you're behind a firewall and you don't have access to EPR Elastic CO, you're going to see there is a problem, you need to configure the proxy support, or there is also parallel work ongoing that you can actually run your own registry. Adding an integration, you can use the policy builder. It tells you to give a name, enable the integration you need, and as soon as you hit here, save here on the right bottom, it's actually going to install the assets and deploy it to your agents. So that was kind of the UX flow. So I recommend you go to Cloud Elastic or set up your own stack quickly to try it out. It probably gives you the best experience. I didn't do a demo today as I really want to go into the technical part. So how is actually the fleet authentication working? So we have Fleet Server uses a so-called service account. That's a new feature in Elasticsearch, service account. So it's basically a user account with multiple passwords or API keys. And the Fleet Server uses these service tokens to communicate to Elasticsearch. And Kibana, with the user you're logged in, creates the enrollment tokens and saves them in an encrypted saved object. The Fleet Server itself, then with the enrollment token, actually creates for each Elastic agent 2 API keys. So that is important to know. So 2 API keys, one is for the access token, basically that you can talk to Fleet Server, and the other one is the output API key, we call it, is that you can talk to Elasticsearch. I see there is a question coming. What is Elastic Agent actually doing? Quick, in a nutshell, Elastic Agent collects data from your machines, like metrics, logs, and it can also protect actually your machine with endpoint security. So going back to Elastic Agent, so each Elastic Agent gets 2 API keys. So if you enroll a new agent, you can actually use the same enrollment token, but you have 2 new API keys created for it. And we manage these API keys for you. So, but if you actually want to say, hey, these Elastic Agent is doing something malicious, you actually have a very easy way to just say block that agent. And by invalidating both of these API keys. Here, one more step on the Elastic Agent UI. You get an enrollment command to install and directly run your Elastic Agent. As soon as you have run that command, it connects to Fleet Server, pulls down the policy, and does its magic to ship data. So let's talk about the technical part of the Elastic Agent itself. As I mentioned before, Elastic Agent is basically a supervisor. And that probably goes into the question of also, Wayne, what does it do? It does many things. It runs actually as a sub-process, metric beat, APM server, OS query, file beat, Fleet Server. And it runs these processes, manages these processes, and communicates to these processes through gRPC. Elastic Agent is actually the gRPC server, and the clients connect to it. You see there is one box outside here, which is endpoint. Endpoint is a bit special, as endpoint security protects the Elastic Agent itself. That's why it's kind of not run as a strict sub-process. So there is a bit of special juggle going on there. It also, if you install endpoint, you kind of need all the permissions on the machine. But after that, the Elastic Agent is protected by endpoint. So what happens during the enrollment of the Elastic Agent? So the 2 credentials you need is, one, you need the host name of the Fleet Server, and you need the enrollment key. So as soon as you send that enrollment command, the Elastic Agent is going to talk to the Fleet Server, give it the API key. Fleet Server is going to talk to Elasticsearch and ask, is that a valid API key enrollment token? If yes, the Fleet Server creates the 2 API keys I mentioned before, one for authentication, one for data ingestion into Elasticsearch. I get on the permission on these keys later on. Short answer on the first one is it has literally 0 permissions, except talking to fleet server. Then the Elastic agent checks in to fleet server. The fleet server sends it down the policy that is attached to that enrollment token. And the Elastic agent, based on that policy, decides, do I need to run metric beat? Do I need to run file beat? It looks at the list and makes a decision on what to run, and these processes then ship data to Elasticsearch. Quick note on the agent files. So in case you have already run Elastic agent, you're going to see a few files laying around. There is the Elastic agent.yaml. This is only used if you actually run it on-prem. Sorry, not on-prem, standalone. So if you didn't enroll into Fleet Server. There is a state.yaml that consists of most recent state that was actually applied to Elastic Agent. And there's a fleet.yaml that contains the credentials around the connections to Fleet Server. So we need to persist that in case of restart instead of a crash, we can take it up again. So I touched before quickly, I said there are 2 modes on how you can run Elastic Agent. So there is a standalone mode, what we call it. That's what you're probably used to from most collectors like Beats, FluentD, FluentBit, is you put a config file there, you start it up, there might be some local configuration reloading, and that's it. It ships the data. And then there's the manage mode. So that's kind of the whole thing we talk about right now is when you enroll into Fleet Server, you can actually manage it from Kibana. Fleet is enabled and all the configs are retrieved through Fleet Server and all the check-ins are made through Fleet Server. So in Fleet UI, you actually see if an agent is healthy, it's alive, and what it's doing. Important for the start of the YAML we had before, state there is only persisted after it is applied. So you might actually say in Kibana, hey, that changed, please apply it. You're going to go to the stored YAML on the local agent. You can see, oh, it's not there yet. It takes some time to roll out and also to apply to do all the changes and the configs. So the Elastic agent itself inside has a bit of process on how to munch the configuration together. So before we saw that under Elastic agent, metric beat, file beat, and others are running. You can say, hey, the config looks like pretty different. And you're right. We try to unify the configuration with the Elastic agent to you as a user should not care which binary is run below it. If that input is run by metric beat or by file beat or anything else, should not matter. So what we implement is kind of a transpiler with a spec file and some rules on top of it that takes existing configuration and actually converts them to the actual configuration of each binary. And we use gRPC for the communication. I see there is one more question here in the chat. Currently, Elastic endpoint is not available in standalone mode. Will it be at some point? If so, is there a rough timeline? That's a good question. So you're right. It's not available in standalone mode. I'm not part of the endpoint team, so I'm probably not the right person to answer this. As far as I know, it's not on the short-term roadmap. I would also challenge how useful is endpoint when you actually cannot remote configure it. But again, I'm not an expert on the endpoint part, so it's probably something that should be asked on discussed.elastic.co. We never give timelines, but if it's even planned, we can probably answer there. So now you have that fully managed running Elastic agent, and how do we upgrade it? So we actually offer the feature that you can go to Kibana and you upgrade it. There are a few exceptions here. So if you install through RPM or if you run it inside Docker, we actually block the upgrade. So in the Docker scenario, we assume you're going to upgrade the container, and we should not modify the Elastic agent inside the container. But let's assume you have it on your machine, or on your laptop or on an EC2 machine, we can actually upgrade it for you. So you're going to go to fleet, you trigger the action that we should upgrade. What the Elastic agent is going to do with that action is it's going to reach out to elasticsearch. It's going to check if the newer binaries exist, validates them, compares the hashes, downloads binaries, actually then compares after download the hashes, extracts them, restarts the Elastic agent. It creates new directories for the new versions, copies over the state. We actually had some bug there recently around the state copying. Copies over all the old state to the new, and spins up the new process, including upgrading itself. So some magic going on here. I mentioned that this happened through actions. So basically what an action is, something that is sent down through Fleet. Again, it goes through Fleet server picks it up, decides which agent it should go to, and then it, based on some configuration related to the input name, it knows where to send it. So one common action we have is for OS query. So when you actually have the OS query integration running in Elastic Agent, you can type queries in Fleet that are executed on your machine, OS query, and you get the results back to Elasticsearch. The results are then stored in the Fleet action results, and the token is used with Elasticsearch to make sure we actually only send down the actions that haven't been missed. So think of it like a queue, and we know exactly where in the queue we are. So the next feature to talk about is dynamic inputs. So in scenarios like Kubernetes or Docker, when you set up Elastic Agent, you not necessarily have all the configurations ready. New containers spin up, new services spin up. So what we offer in Beats, we have auto discovery, and kind of the same feature exists in Elastic Agent. We just call it dynamic inputs. And each dynamic input has a provider, a data provider for Kubernetes, for Docker. We actually plan to add more in the future. But what it allows you is kind of to add some logic into it. So if a new container spins up, you see the new container ID. It's actually going to collect for that container ID now too. And you can even use conditions. It's very similar to the EQL-based query language. It's not 100% the same. It's unfortunately one in Golang and one in Java, but in general, it should be pretty straightforward. You can take variables, compare them, and add conditions. So there is an additional question from around. Can you enlarge that one, Dalia? Thanks. So the idea was to be able to use endpoint while using log/output, which is for the moment only available in standalone mode. Yeah, we actually work on supporting multiple outputs through Fleet. It didn't land yet. There's some challenges around it, but it is on the roadmap that we support multiple outputs, and of course also log/. So we have all these processes running, metric beat, file beat below the Elastic Agent. One important part is we also need to know how these processes are doing. One, for Elastic Agent to kind of kill a process or restart a process if it's not healthy. Second is to actually get metrics on it and logs on it and how the processes are doing in Elasticsearch. I mean, the Elastic Agent is in the end to do observability, to do security on the machine, so it should do good observability for itself. So we kind of dog food FileBeat the metric beat for that. So we run FileBeat the metric beat to collect our own logs and our own metrics around the processes and around how they are doing, and ship these to Elasticsearch. And here is actually the answer: multiple outputs coming in the future. So today you actually have to ship your monitoring data to the same Elasticsearch cluster. which might not be ideal or whatever all the users want. It's a limitation we have in place. We work on actually supporting multiple outputs, multiple Elasticsearch cluster, Logstash in the future. So debugging the Elastic agent. So as you have a supervisor with processes running under it, unfortunately, debug is not always as easy as it should be. And it is something we work on to make it easier to access all the logs, get all the detailed status of it. Part of that exists today. So the two most important commands are Elastic agent status. It's actually going to tell you how the status is of all the daemons and subprocess that the Elastic agent was starting. The second command is really useful to figure out what is actually your Elastic agent running that is connected to Fleet. So you made a change in Fleet and you ask yourself, what is running exactly? So that's when the inspect comes into play. You can select the output you want to have the configuration for, and it's actually going to do dynamically substitute all the variables from the dynamic inputs and tell you what the exact configuration is right now. That's a great tool for debugging. More to come on that front. So that was around the Elastic agent. Now let's dive a bit into Fleet Server, because that's a component we introduced exactly about a year ago. So how does it work? So under the hood, Fleet Server is actually just another input in Elastic agent. You could, in theory, run actually Fleet Server on its own, and that's how we develop it. We built it as an input into Elastic agent, so that by default, if you just want to get started, you actually can just run Elastic agent with Fleet Server. And it means you actually only have one binary that does it all. It also gives us the advantage you can actually go to Fleet and reconfigure Fleet Server. So it's just another input and another binary. It has its own configuration and also ships some data. So the Elastic agent and the Fleet Server that's running below it, they communicate. So when Elastic agent has a Fleet Server running inside, it actually always communicates with that local Fleet Server. So it basically connects directly to get all the configuration and updates from there. By default, it's a self-signed SSL certificate. Of course, you can provide all the CAs and certificates to have your fully signed certificates. So the initial enrollment of Fleet Server is a bit of dance, because we have a chicken egg problem. An Elastic agent can only be started with a Fleet Server, but the Fleet Server needs an Elastic agent to run. So there is a special flag that it passed to Elastic agent when it started up. And what it does, it starts the Elastic agent and directly spins off the Fleet Server in Bootstrap mode. And it only starts Fleet Server. Then the Fleet Server actually gets the enrollment token and pushes it back to the Elastic agent over the gRPC communication channel that was open. Then the Elastic agent calls the enrollment command, communicates with that fresh Fleet Server, and completes the enrollment. At that moment, when the enrollment is completed and has actually persisted on this, the Elastic agent restarts itself and comes up with the new configuration, including Fleet Server. It fetches the policy that it needs and then just operates like any other Elastic agent. So one thing we have seen is that actually some users do exactly that and later on decide to remove the Fleet Server integration and the system falls apart. It's something we want to block in the future. But you can see what happens is you have an Elastic agent that talks to its local Fleet Server. And now you're going to take away the Fleet Server it talks to. So of course, it stops communicating with the whole system. So if you have a Elastic agent with Fleet Server, please keep the Fleet Server in there. There is also a bit magic around the whole Fleet Server policy rollout. So the Fleet Server has a so-called coordinator inside that doesn't do much today. But this coordinator is basically to decide to which agent do I ship which policy. So as soon as Kibana adds a new document to the fleet policy, a revision on that document is incremented and the coordinator ID is 0. If you have multiple fleet servers, one of the fleet servers is elected as the leader for that policy, and from there on is staying the leader for that policy until, for example, that fleet server disappears. It is important that we keep some state around who is the leader. So not we kind of have a split brain of two ship out the same config. So from here, actually, the coordinator generates a new policy revision to say, hey, I picked it up. And if two try to pick it up at the same time, the whole game starts from 0 again. And as soon as we have that leader, the fleet server puts the policy there and is shipped down to all the Elastic agent. The shipping down, that's important, that can actually happen by all fleet servers. So it might be that one Elastic agent is connected to fleet server A and the other one to B. Both of them can actually serve the same policy. But we still need to have a leader that kind of controls updates to the policy. So about the coordinator, at the moment, it doesn't do much. It just copies the policy from Kibana. There are some ideas we have in the future on that it could do more to kind of be more specific on what should be shipped where onto which Elastic agent. At the moment, all it does is based on the enrollment token. And of course, we also want to make sure it provides better high availability across Elastic agents. So if you want to have high availability today, you either need to put in multiple fleet server URLs or you put a proxy in front. Yeah. Because otherwise, if you lose the connection, of course, things can become interesting for the Elastic agent. Sorry about that. So here quickly again for the indices, I mentioned them in the beginning. We have about 8 of them right now. It could be that we have more. The name should be pretty self-explanatory. So actions is for everything that is targeted as an action to a specific agent. The results are shipped up as an outcome of the actions. The fleet agents is just a list of all the agents that are enrolled in the system right now. Artifacts is something actually endpoint security uses to ship down new rules. We have more ideas on what kind of artifacts we could ship down, but think of it, one of the inputs needs a newer artifact. That's where it's received from, and it's not just sent down through the standard channel because it might be too big for that one. Then the fleet enrollment API keys, the enrollment tokens, we keep track of these to make sure we can also clean up. Or actually, for example, we have a TTL on some of the agents so that we can say if the agent didn't react for 10 minutes, we actually remove it from the system. Then we have the fleet policies. So the policies we ship down to the agent. The leader, that's what we touched on before, that we know which fleet server is the leader for a specific policy. And we have a list of fleet servers that are running. So if we want to elect the leader, we have an up-to-date list on how many fleet servers are around. There is one last detail I want to touch on, which I think is very interesting with the managed Elastic agent, and it's ingest permissions. So in Beats today, you actually have to hand out quite a bit of permissions because it does the setup and you ingest the data for Nginx, for Apache, for system, all into the same index. So whoever has access to Nginx has access to Apache too. So because of the new data stream naming scheme, and I don't know if you can link that talk somewhere afterwards, but we basically split up the data for Nginx, separate from Apache, from system. We have much more granularity. And what actually allows us to have very fine-grained permissions per policy. So if you if you roll out the new policy to Elastic Agent, the fleet server is going to look at the permissions this policy needs. So let's say it's going to need logs dash nginx.access dash default. An API key is going to be generated with only these permissions. So if now suddenly someone takes that API key and want to ship data to logs-foo.bar, the user doesn't have permissions. So every time you update a policy, actually new API keys are generated with exactly the set of permissions you need. This increases security that some of the API keys might be reused, and also because actually the setup happens in Kibana around installing ingest pipelines and all these other things. It's also, you actually never need these permissions. You only have append-only permission. One thing we still look at, quite a few of our integrations actually use dynamic templates, which means you could trigger some field explosion. We try to limit that too, so that, for example, endpoint security doesn't use any dynamic templates anymore. So basically, the only thing you can do is append data, and that's all the permission the API keys has. So we keep working on limiting the number of changes you can make with these API keys, and we can do that because we actually know exactly what is running, what permissions it needs, and it's fully automated generation of API keys. Of course, in standalone mode, that's much harder because you basically had to go through that and figure out for each one which permissions you need. You can do that, but it's more work. So that's all I had for today. As I said in the beginning, it was a pretty technical talk. I went through a lot of details of elasticsearch, fleet, and fleet server. So I really hope there are some more questions in the chat to jump in and to answer. So yeah, please start typing.
Let's see. I'll wait with you to see if we have any questions.
Dolly, the presentation can also be watched afterwards as a recording?
Yes, exactly. It can be watched on our YouTube channel. I will put a link right now, actually, in the chat so people can know where to find it. Yeah. Okay, I just inserted the link, so it will be automatically actually uploaded there, so you can rewatch it anytime after we finish now. Yep, there's one question.
Yeah, can you? Okay, concerning the API, where do we do the calls? To the API server or to Elasticsearch or to Kibana? Question is which API calls. So for all the configuration, for example, set up a new policy, there is a so-called pre-configure API that you can say, that's a state I want, which we still improve that it works better, for example, in Kubernetes, that you can just put it in a manifest. But most of the calls, API calls, you're going to think about for the policies, actually all of them are directed to Kibana with the Fleet plugin. I hope that's the one you were thinking of. And there is another one.
I think from Wayne before that.
Does this replace metric beat and APM, etc.? So it actually does. So under the hood, it runs APM and it runs metric beat. So it is not as powerful yet as these two. So APM and metric beat are going to stay around for when you actually need the full features. But it is a complaint we had, is like, why do we need to run 5 binaries if we want to collect metrics, logs, and APM? And with elasticsearch, you only have one, and you as a user don't care what is run below. If it's 1 binaries, if it's 5 binaries, we manage all of it for you. So you have a single configuration. So you can run it on laptops, you can run it on your host, you can run it in Kubernetes, exactly like metric beat, file beat, and APM. There is another one, are fleet servers and agents terraformable on Kubernetes? That probably ties into the question around the pre-configure API. So yes-ish. I would say the experience is not as great as it should be. It's definitely on our list to improve configuration through code. step by step. If you're interested in it, definitely look at what we did for ECK. There is a first step. There is an alpha version of elastigation of fleet server in ECK, which I would argue is kind of similar likely to the Kubernetes part in Terraform here, but it's not as shiny as I would like to have it already. Oh, step by step. There is one more question about fleet server and synthetics monitoring. Sometimes will be performed directly by fleet server, or should I enroll a basic elastigation? So to clarify, you always need the elastigation. I assume what you refer to, can you run it directly with the elastigation that also runs fleet server? And the answer is yes, you can. Keep in mind that the elastigation with fleet server, of course, is a lot more permissions. So if you run 5 or 10 elastigations for synthetics, I would likely run a separate one for fleet server to just have it independent, or use the one on Elastic Cloud. But if you just have one, yes, of course, you can put synthetics inside, just run it there too. The next one, can we set up elastigation in air-gapped environments where agents do not have direct access to Elasticsearch and sent to Logstash instances? So it depends. So actually today, it's not fully supported, but you can actually configure Logstash output for elastigation. And now comes the important bit, in standalone mode. That you can do today, and it works. It's, as I said, we work on making it fully supported, but it works. So for when you actually enroll it into Fleet, you of course need to have access to Fleet server. That needs to be run somewhere that Fleet server has access to Elasticsearch and has access to elastigation. And for the Logstash instances, so for sending the data, we work on that Logstash output. It's not there yet in Fleet, but we'll get to it. But keep in mind, if you want to have it managed, there is a part, the Fleet server, the elastigation with Fleet server, that needs to connect to Elasticsearch, and your agents need to connect to. So the next one is it possible to set different lifecycle policies for different agents? Are you referring to ILAM policies on the data, or what kind of lifecycle policies are you referring to? Maybe you can follow up on that question to make sure I answer the right one. Let me see how quickly it's going to type. Let's take another one in the middle until we have the answer. Could fleet server run directly on the same Elastic nodes? In example, ES cluster with 3 nodes, so 3 different fleet server instances. Is a good idea to collect components? First answer is yes, it would work. It would become interesting because actually the way it works right now is that even if you run it locally to your Elasticsearch, each fleet server will connect to all three nodes still, because you or if you have a proxy in front, it will connect to the proxy. But because you run it locally, you could actually configure localhost. But in general, I would probably not put it on the same machine if you really want to have it production scale up. So you have an endpoint for Fleet, you scale the Fleet servers differently, separately from the Elasticsearch differently. They might have actually also different memory and CPU consumption. So kind of you're going to be able to scale them differently. So especially thinking of Kubernetes, you would have separate containers and not put it on the same machine necessarily. You could. I would not recommend it. Index lifecycle policies. We have as for the previous question on if you can set per agent. So it is actually not per agent. So but what you can do is set policies. So what you can do is there's a concept called namespaces per policy, and that namespace applies to where the data is shipped in that data stream naming scheme. I really recommend to have a look at the data stream naming scheme blog post. I'll post it into the chat. Give me a second. If I can post in the chat, I cannot. That's interesting. I'll send it afterwards. Dahlia, if you can.
Yeah. What do you want me to post?
Yeah, I can.
I think you should. You should be able to post in comments.
Somehow the comment box doesn't show. I send it to you over Slack.
Okay,
But,
I will post it
so,
now.
what you can do now that you have these namespaces for the different policies is you can actually assign through the component templates in Elasticsearch these different island policies. So you can say all the namespace foo and all the namespace bar in the data streams have these policies. So it's exactly what you get. You have island policies per policy. The UX around it is a lot of manual work at the moment, but it's something we want to fix in the near future to give you a better experience around it. So possible, yes. Recommended, yes. UX, not ideal yet. Some more questions?
You answered a lot of questions. Let's see if there are more.
Let's give them one more minute. And otherwise, I don't know, Dolly, if you have any slide, but there is always discussed at elastic.co to ask further questions. We're pretty active there, so feel free to drop questions there. The team can answer them around fleet, around Elastic Agent, package registry, all these things. And of course, all we do is on GitHub and public, github.com/elastic/beats/Kibana and everything. Yeah.
Okay, I just put it in the chat if anyone wants to ask questions on Discuss.
Yeah.
Oh, there's one more question.
So, fleet server instance should be around CPU consumption or memory? It's interesting you ask. So the simple answer is CPU, as long as you have enough memory. So I'm saying that because as if you go below a gig memory, or things become memory bound, but if you go up from there, it becomes CPU bound. So Elastic Agent with the processor running below it uses like a certain amount of memory, and especially during enrollment time, you just have a certain cache. But from there, if you scale up, it's CPU bound. Is there any recommended size? Actually, yes, we have. Not 100% sure if it's public yet, but we actually have a sheet where we basically say 200 agents, please use that configuration with that size. We kind of developed that for cloud, but it of course applies also to you on-prem. I'm not sure if it's public yet, but it's going to be public soon. So we have a recommendation, yes. When would you use the standalone mode instead of fleet managed mode, now that both talk only to the fleet server? So actually standalone mode doesn't talk to the fleet server at all. It only talks to Elasticsearch directly. So standalone mode is really if you don't want to have it managed, is one of the criteria. The other one is some features are not yet supported through Fleet because we don't have the UI yet and the APIs for it. So actually in standalone mode, you are able to get a bit more features, but it's also harder because you need to configure it all yourself. So I think the question is really, do you want to have it managed, or you actually, for example, run everything with Puppet and Chef, and you don't want to have it enrolled, or you cannot talk to Fleet Server directly at the moment? We try to get rid of all these arguments, not to use the managed Elastic Agent, but there is a gap we still need to fully fill. Dahlia, you're still there? Oh, yeah.
Yeah. Just waiting to see. Maybe we have one last question. If not, we can wrap it up. Yeah. If anyone has an interesting use case they would like to present in our meetups, please get in touch with us. Send us an email to meetups@elastic.co, and we can take it from there. Thank you very much, Nicolas, for the great presentation. Thank you very much everyone for attending, and we'll see you again at our next meetups then.
Yeah, thanks for having me.
Thanks, everyone.
Listen.
Bye.
Here.
Bye.